In the previous part, you have seen how you can choose the two built-in character sets by setting the character pointer. What we're doing in this part is actually copying the ROM character set to the RAM in order to only modify some characters. So first of all, I want to add some order and comments here. So this is the high byte of character set pointer. Actually, there is only a high byte, there is no low byte. I'll explain this shortly after. Then we have the location where we place the character set. And this one is in 0 page, so I ordered them here. And this is character set in RAM. Okay, alignment. A typical pattern that you will find in hardware is that if you have something that has a variable memory location, you don't make it fully flexible where this memory location starts. A character set, for example, takes 1 kilobyte of data, and therefore it has to be aligned to a 1 kilobyte boundary. 1 kilobyte means at 000 or at 00400, or at, in our case, the next free 1 kilobyte block after the code would be at 2400. Let's show what happens if you ignore the alignment typically. This is how it originally looks like. So what happens if we change this now to, let's say, EOFF? Well, nothing happens at all. What's the reason? The reason is this pointer is just the high byte. Yeah, that means the upper byte where the character starts, and it does not have a low byte for the pointer anyway. So what happens if we change the high byte? Wow, nothing happens, but we've seen that something can happen, so let's increase E2, E3. Still nothing happens. If I put it to E4, you now see there is garbage on the screen. What you see here is the content of the operating system ROM, and the reason why we see it now and didn't see it before is that we have now with E4 reached the next 1 kilobyte boundary. So what you have to remember is there are certain things that have to be aligned. One of them is the character set. In graphics 0 mode that you have seen here, it needs to be aligned to 1 kilobyte boundary, so we put it at 2400. And if we just do it like this, we see nothing except the inverse characters of nothing, because currently the RAM there is still empty. So the first thing that we have to do is we should copy the original character set there. So let's call this the ROM chars. They are at E4. Oh, no, they are not. They are at E0. And now we have to copy 1 kilobyte of ROM into the RAM. The simplest way to do this is to do it via pagewise. That means copy 265 bytes in a row. So we load it from there and we store it there. We need a loop with x counting from 0 to 255. And if we do this, we copy the first 200. Oh, yeah, I should call it the same. And as you can see, I have copied the first quarter of the character set. Now I have to do the same for the remaining parts of the character set. And for this, I now introduce a short form. It's a built-in mechanism in METS. It's like poke in BASIC, and it is just making your source shorter. So I can write what I wrote here in a way that I write it shortly as move with the accumulator the high byte of the char to ch, and in the same way I can now move from here to there, and this simply makes my source code a bit more readable. It doesn't change anything semantically. So we copy the second page and the third page. Let's see how far we got. Almost nothing is missing, only the lowercase letters are missing, and they are the 4th page of the character set. And similar to what I did here, I can now start and redefine characters in that character set. To that, I obviously need some data. So I define a data block again, and I put in, let's say, some binary values. 1, 2, 3, 4, 5, 6, 7, 8. And I put these binary values in here with single byte statements and with a % sign that it indicates it's a binary value. 1, 2, 3, 4, 5, 6, 7, 8. Because there are 8 characters are 8 lines, 8 bytes, 8 bits, 8 bits high and 8 bits wide. And I've painted a bit pattern here. So what we have to do is now we have, of course, to copy that local bit pattern into some character, and to make it more obvious, I choose the first character in the character set, which is typically the space. But instead of the space, you should then see, let's call it a space loop. And I move the content of char set plus x to, it's not that readable. And we have to copy 8 bytes, so I increment x, and if it's, compare it with 8, and if it's not yet 8, we loop. So this is also a nice opportunity to introduce another feature of MEDS. As you have already seen, procedures and local areas can be nested, and they can have inner labels. This makes it possible that we call this a space, and you see that this is now available for navigation. And here we use space as a local label. Local labels are always separated by dots, and you can continue nesting them and with locals and locals and procedures. And if we start this program now, what do we see? Wow, there is something. It is obviously the pattern that we have drawn with a bit mask, but it's flashing. So why is it flashing? Well, it's fairly simple. There is a loop. This loop jumps to main. Main starts copying over the character set from the ROM again, and then copies in our character set. So this is why we see it flickering. It's changing all over the place. And what we really want is we want the program to stop here. And here in assembler is the star. That's the current location of the program counter. This is equivalent to jumping to this. This is shorter. So if we click here, then we have the character that we wanted. Well, not exactly. This is an Atari tutorial, so this is a totally silly pattern for something that's called space. So I add this here and show you in a minute. What I also wanted to add, you could of course also use the international character set as the basis for copying from the ROM. My recommendation is not to do it, because there are actually some operating systems that use the area of the international character set for other purposes, like putting in there some speeder routines or maybe machine language monitors. Therefore, if you use a character as a template, please use the non-international standard character set. So, if you did not recognize that pattern, I think it's the best pattern to end that section on an Atari tutorial. It's of course our beloved alien, and see you in the next section.